Please done this. Type error. Swaras, leave it. After the class, spelling is wrong, man. Yeah. Now, scaling part completed. I'll use my text size as 20%, random state 0. Just go here. Now, what is total data set I has? Data dot shape. 398 rows and how many columns, guys? 11 column. Out of 11 column, we deleted one column. Which column is deleted? Anybody? Which column is deleted? Car names, the categorical value we have. Car names we deleted. Now 10. Out of 10, we use 1 for dependent, 9 for independent, right? X train, X test, Y train, Y test. Test size 20%. Okay, we apply X underscore S or not? Because we scale it. We apply scaling, guys. Just go ahead and execute. I think we already done. And you can create a variable and print type of X underscore S and okay, anything I done wrong? Okay, that's good. And print, just copy, paste here. So type, okay, I can say X train, X test, Y train, and Y test. What happened? His spelling is wrong. I'm sorry. Close, 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 and close. Check, I think I want to apply a, okay, sorry. This length. Do you see this case or not? Guys, I hope understand. You can check the X train. Okay, Y train, Y test. We already, we have 318, 398. We 318 we use for train and 80 refers to test, guys, done. Now let's go ahead. Can we build simple linear regressions model? Team, are you done up to this? How many of them completed? Good, 2 only. What about rest of them? Offline team. Finished or not finished? Where you stuck? Okay, Bhupinder done. Very not finished. Sushma, okay, let me know which one. Done. Very good, Jugaib. Sushma 18th. Why are you guys doing so slow? Data dot drop mpg x is 1. 18th. Please write 18th. Check now. Done. Raman, it's working now. And whoever got Swaraj and Sushma fixed it or still the same bug? No. Same. I think you've done something wrong, man, because check the variable, check the names. Not most of them people getting accept you. After you fix you check, still same. More time. First, we import all this library. Okay, let me complete, then I'll share the notebook. You can work after that. Okay. Updated Jupyter. Why you updated Jupyter, man? You need to update any Jupyter. Okay. Let me share. So guys, 23 lines complete or not? We split the data into X train and X test. Can we build simple linear regressions model? Write this. Regressions model, linear regression. We fit X train, Y train, or X test, Y test. X train and Y train. We fit this model. Now, do you know enumerate function we used before? What is enumerate? It gives us paid object. For IDX column name, in enumerate xtrain dot columns, print the coefficient. Okay, I just copy it, and one moment, I want to give it to here. Try this and post. Now copy the code and paste here and try to understand. So the moment when I execute, can you tell me how many independent variables I have, guys? How many independent variables I have? 9. So 1, 2, 3, 4, 5, 6, 7, 8, 9, 10, 11. Yeah, 10 or 11. Just 1 second. Okay, sorry. 10 I have the intercept, guys. Constant. Guys, are you clear? See this code. We have total 11 attribute. Out of 11, I eliminate the car names. Now, in this code saying, give me the coefficient of my independent variable. Now, if you see my data set, MPG is a dependent variable, leave it. COIL, cylinder, coefficient is 0.24. Dispersion coefficient is 0.29. HP coefficient is minus 0.18. Are you generate the coefficient or not? Can you please let me know, are you guys generated the coefficient? So today you understand how to generate a coefficient of each and every value. See this, enumerate xtrain dot columns. Xtrain, we have these columns, pretty clear. Print coefficient dot format. I will explain in functions what is the meaning of format function, guys. Column name and regressions model coefficient IDX. So the moment when you done this, and it will generate 10 coefficient. And what about this last line? This is a intercept. This is a intercept, means constant. Now we can fit ridge model. Let me know once you complete. Exactly. It's a string format. That's right. And we'll tell you in upcoming classes what is meant by string format. How many of them done? Error? Enduku? Got error. We got coefficient or not? What is ridge now? Okay, online team, just stop. Let me finish and I'll post it. You can complete and let me know. Okay, so I think regressions underscore model fit capital X. Do you pass capital X or small? I hope everyone understand up to this or not. So we have coefficient. In this one, do you see 0.24 is highest coefficient or not? 29 is highest coefficient. 29 is highest coefficients. 0.34 is coefficients, guys. The moment when I apply ridge, this 24 has to reduce or it increase? Has to reduce. Now, in ridge, I'll pass 0.3 because I done multiple parameters check. And when I find out, do you see 0.2463 to reduce to 0.2434 or not? And here 29 has reduced to 28. If I pass 0.4 and check this, okay. Now if I pass 0.2, so the best way I check based on multiple check, I pass 0.3. Now 29 has reduced to 28 too. If I pass 4, it is 28. Guys, you getting my point? And then 0.18082, 1807, reducing or not? So 66, negative 66 to 65. And then here 34 year. So what is this? 0.34 to which one? I think you can change to 34.7 to 81. Guys, do you see some values are reducing or not? This concept is called ridge regularization. This concept is called ridge. What if I apply lasso now? Just go ahead and execute. Do you see 24 had scaled down to 0? 24 had scaled down to, and 29 had scaled down to again 0. So how many element attributes? 1, 2, 3, 4, 5. Just go ahead. 5 attributes remove or not? we notice many coefficient turn to 0, indicating drop these dimensions from the model. So guys, I hope you're clear. How many of them understand? How many of them understand, guys? Theory, practical, both are matched. So in interview, anyone ask what is regularization technique? Would you explain or not? Would you explain what happened? Which is feature elimination? Lasso ridge. Lasso, how? Because these values we reduce to 0. These are eliminate. So L1 has more power than L2. But in the code, sir, only about alpha. Okay, Venu, if you shift tab, the alpha has 1.0, the model given to you or not? You apply shift tab. Okay, now you can refer based on shift tab. So here in the equation, which had square? Lasso ridge. Lasso ridge. So which parameter should increase? Lasso or ridge? Ridge. So can I increase my parameter? If I add 0.1, then this value also gets 0. It doesn't make sense. Now you try with 0.2. You can compare. So the best way, I pass 0.4 to get my coefficients. Now if I score comparison, X train, Y train, bias or variance? X train, Y train, bias or variance? X test, Y test, variance. Now see the score. Is it a good model or not? Simple linear regressions model, low bias, low variance score. Ridge model, low bias, low variance score. Lasso model, low bias, low variance score. So I hope you understand. So how lasso ridge works, things would be fantastic. Clear now, guys? How the coefficients reduced? See the equation, we connect with practical, we reduce the coefficients, and practical is done. Perfect. Let's go here. The last part is feature selection technique. This things is a data mining technique, which I will just give a quick explanations about this tomorrow. Or maybe let me complete this feature selection technique. In data mining, so practical, are we understand, guys? Can I move on to the next part? Online team, can I move on to the next part? Yes, guys. So rest of them, please, I will post this notepad file, close, and you can work and update me. You can work and update me. Next one. Okay. Feature selection technique. How many features we understood? The first, business understand, then RFE, then lasso. 3 technique we done. If I refer, still your recruiter not convinced. So feature selection techniques in data mining. We have a data wrangling, data mining, all things comes under data cleaning itself, guys. Okay, the naming itself is different. Okay, now in feature selections, we have 3 methods. First one, filter method, wrapper method, embedded method. The recursive feature eliminations comes under wrapper method. In filter method, how do you filter the attributes based on information's gain? I will explain in decision tree. Chi-square test, just now I'll explain. Correlations, do you know correlation or not? So because of the correlations, we can find out the right filter attribute or not. Because of the correlation, are we filter attribute? Yes or no, guys? If we have negative correlations, so don't you think the correlation comes under filter method? Clear this part? Okay, this part is done. Now in this filter method, I will explain information's gain concepts in decision tree, not now. So leave it because we have decision tree future. Chi-square test, I will explain now. It's just a theory. We have G-test, T-test, guys. The same way we have chi-square test. Correlations, we already covered. Filter method, we done. Next, wrapper method. In wrapper method, genetic algorithm, leave it. Theoretically part only, it is important, not required. RFE, are we done or not? Recursive feature elimination, backward elimination, forward elimination. We compared this eliminations with the p-value, So this is called wrapper methods. This is called wrapper methods. The next one, embedded methods, decision tree. I will explain this one. I hope understand everything's be complete. Just chi-square test and rest of things I'll explain later. Genetic algorithms not required. Genetic algorithms not required. Okay. There is a two students placed. Let me finish and I'll leave. What is meant by chi-square test? Listen to me. This table shows the number of accidents happens during days of a week. How many days of a week? 7 days. You need to test whether these accidents are uniformly distributed or not. So Monday, 14 accidents happened. Tuesday, 18 accidents happened. Wednesday, 12, don't ask a questions why accidents happens. Me too don't know because this is an example. Okay. So Wednesday, 12 accidents happened. Thursday, 11 accidents happened. Friday, 15 and 14. Total accidents, how many? 98. So in the questions, the DF is 6 and x squared 0.05 equal to 12.5592. This is the questions given to us. We need to test this use case using chi-square test. And the formula of chi-square equal to G equal to x minus mu by sigma whole square. If the value x square is less than xt, then look at this, guys. Now, understand this formula. Let's apply the test case. The first one, this is observed value, this is expected value. Now, understand this. So here, O minus E, what is expected test? 98 divided by 7, 14 accident or not? In a week, 7 days. What is total accident? 98. 98 by 7 equal to 14. So expected accidents are 14. We take an average. Clear? Now, Monday actual 14 accident happened. So can we say the formula observed minus expected? 14 minus 14, 0. And 18 minus 14, 4 goes on like that. 12 minus 14 minus 2. 11 minus 14 minus 3. 15 minus 14, 1 and keep goes on. And then O minus E whole square, 0 squared 0, 4 squared 16, minus 2 squared 4, minus 3 squared 9 and goes on. Now if I apply the formula, what is the value? The value is 2.14 or not? So when we have 2.14, do you see what is x squared 0.05? 12.592. So 2.14 is less than 12.592 or not? That means the hypothesis is accepted. Accepted means the accidents are happened so uniformly because 14, 18, 12, don't you think an equal uniform accidents or not? If the x square is greater than x squared 0.05, then this is not a uniform distributions, guys, x squared. So we test this use case. The name of the concept is chi-square test. The name of the concept is chi-square test. What is the formula? This is the formula. Very simple way I'll explain. Every sessions, if you listen the recording, the classes is very simple. I'm speaking simple English. If you do not understand, then it is your problem.